Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Okay. Now, nerve impulse conduction along the nerve fiber. We are understanding that how the nerve impulse conduction will take place along the nerve fiber, that is the along the total length of the nerve fiber. So how many steps are there we discussed yesterday? Anyone? Speak up. What are the steps involved in the nerve impulse conduction? Neha, are you there?
Yes, ma'am.
Okay, so speak up. बोल दिया करो, नहीं तो समझ नहीं आता है कि you all are listening or not.
Yes, ma'am. Ma'am, there are three steps in the nerve impulse conduction along the nerve fiber. First is the resting potential, second depolarization, and third
हाँ.
repolarization.
Okay, depolarization and the repolarization. Okay. So now I was telling that the cell membrane of the nerve cell, it is polarized, means it is in the excited state. And why it is in the excited state, can anyone tell?
Due to the
Rumisha?
selectively permeable ion channels in it.
Voice is not clear.
The membrane polarized due to the presence of selectively permeable ion channels in it.
Okay, correct. So that's why we say that the it is polarized. So where the sodium ions are more, I ended up there only in the previous period. Can you tell me, Rumisha? Yes.
Outside the
Can you
membrane.
tell me, Acha, voice is cutting. Neha, can you try?
Ma'am, can you repeat the question?
I'm asking that where we find the potassium ions more and where the sodium ions.
Ma'am, sorry, sodium ions are more outside the cell and potassium are high inside the cell.
Inside the cell membrane. Correct. Okay. So first stage we say resting potential, means जब भी impulse नहीं आया रहता है nerve cell पास, तब तक the cell membrane of the nerve cell is in the polarized state, and we say in the resting potential. And in that resting potential, we find that the sodium ions are more outside and the potassium ions are more inside. And we take up that outside it is positively charged and inside it is negatively charged. This much is clear to you. So sodium potassium pump is operating through the cell membrane. Now what will happen when the impulse will come? When the impulse will reach there, so then the permeability of the cell membrane will be altered. Okay, it will be changing. So now try to see here excited neuron. Write down the second step. Only that much you remember. Did you note down this thing? The first one, the resting potential. Resting potential first phase, write down. When a neuron is not conducting any impulse, it is said to be at rest. Write it, everyone. Put the subheading resting potential and then write down when a neuron is not conducting any impulse, it is said to be at rest. And it maintains a potential difference across its membrane. Write it all of you all. And maintains a potential difference across its membrane. Across its membrane, which is usually about minus 70 MV. Noted, everyone? Neha, speak up.
Yes, ma'am.
Noted this much. Then write down. Thus, during this stage or during the resting potential, the sodium ions are more outside the cell membrane and is positively charged. And potassium ions are more towards the inside or inner side of the membrane and is negatively charged. How many have noted? Speak up quickly.
Yes, ma'am.
Neha noted.
Yes, ma'am.
Yes, ma'am.
Barbie,
Yes, ma'am.
Shravani, Rumisha.
Yes, ma'am.
Okay, shall I now pick up the
Yes,
next
ma'am.
stage? So is this stage very clear कि जब तक के सेल में नर्व सेल में कोई अदर इम्पल्स नहीं आता है तब तक के वो रेस्टिंग स्टेज में कहलाता है. And in that resting stage, it will maintain the potential difference, and that difference will be how much? Minus 70 MV. And why we say that it is maintaining a potential difference? Because it will be polarized, and you will find that outside the membrane it will be positively charged and inside it will be negatively charged. The sodium ions will be more outside and potassium ions will be more inside. Is this much clear to everyone and noted also? Rumisha,
Yes, ma'am.
Rumish. Okay, shall I take up the next stage now? Okay, now it starts. Now what you have to understand, impulse has come. Impulse has reached the nerve fiber. जैसे ही impulse आएगा तो nerve fiber will get stimulated. So write down the next stage as depolarization. Second, you write down depolarization or action potential. Depolarization or action potential. This is your second stage or second step in the conduction of nerve impulse. Now what will happen? So write down, when a nerve fiber receives the impulse, when the nerve fiber receives the impulse, it is stimulated. It is stimulated and there is a marked change in the potential. Marked change in the potential across its membrane. Across its membrane. And it changes from minus 70 MV to plus 30 MV. Noting everyone. Neha, say.
Yes, ma'am.
Okay. So minus 70 MV to plus 30 MV. Now change the paragraph and write down that when a stimulus reaches the site A, when the stimulus reaches the site A, membrane, the membrane at A becomes permeable to sodium ions. Becomes permeable to sodium ions. Now when it will try to understand, sodium was outside, sodium ions were more outside and potassium were more inside. Now what will happen as the stimulus will reach there, you find that at that site उस membrane के उस part में क्या होगा, permeability will alter. And how it will alter? You will find the sodium ions के permeability बढ़ जाएगी. Sodium will start move from outside to inside. Are you getting everyone? Yes or no? Speak up.
Yes, ma'am.
हाँ, यहाँ क्या हो रहा है, जैसे stimulus आ रहा है, anyone if you don't understand ask, because it is a new thing, you are not you have not studied before. Okay, so it is all about the permeability, and in the electrochemical form, the ion form, the movement of the impulse will take place from one part of the nerve fiber to the next, and each site is you find adjacent. Okay, so here the diagram is not clear. Just understand, then I'll show you one more diagram and you will be understanding. So एक के ऊपर क्या हुआ है? What is where the stimulus is reaching? Yes, Rubisha.
Ma'am, will you
Yes,
please
yes.
repeat? Actually, your voice was not clear.
अच्छा, voice gone. Okay, I'm repeating. That when the did you note down what I have said? The polarization or action potential states. Munisha,
Ma'am, will you
right?
please repeat? Yes,
Okay,
ma'am, I
I'll
have
repeat it.
written.
Okay, you have to write down it. अच्छा, second stage written depolarization or action potential. Noted that?
Yes,
Rumisha, yes or
ma'am.
no? Okay. And then you
Yes,
have to
ma'am.
write that when a nerve fiber is stimulated. Noted. So can you read it? Everyone can check once. Rumisha, read.
When nerve fiber, voice is clear.
Little starting. Say again.
When nerve fiber,
The problem is there.
state.
It's cutting, na? So I want Shravani to read. Shravani,
Yes,
can you
ma'am.
read what you read?
Yes,
Rumisha,
ma'am.
check. Shravani, let me check your voice.
The nerve fiber
Start,
receives.
Shravani. हाँ
Ma'am, am I audible?
Okay.
Ma'am, the nerve fiber
Yes,
receives
say.
the impulse.
हाँ
It is stimulated, and there is marked change
हाँ,
in the potential across its membrane,
correct.
and it changes from minus 70 MV to plus 30 MV.
Okay. Then after changing paragraph, what did
When,
you note down?
when a stimulus reaches site A, the membrane A becomes
Yes.
permeable to sodium ions.
Yes.
Ma'am, what?
हाँ.
Ma'am?
Noted this much?
Yes, ma'am.
Noted this much? Okay.
Yes,
Now
ma'am.
write down. हाँ. Does the sodium ions start moving inside? Does the sodium ions start moving inside and the potassium ions start moving outside? starts moving outside. Thus, the membrane gets depolarized. Thus, the membrane gets depolarized. And the electrical potential difference at this point and the electrical potential difference at this point is called action potential. Is called action potential. Now you find that at one side the change is there. Okay, क्योंकि बाहर प्लस था, अब क्या हो गया, अंदर प्लस हो गया, बाहर नेगेटिव हो गया. Now the membrane is, that means the polarity is adjacent to it. उसके साइड में आप देखेंगे that प्लस अभी भी बाहर है और माइनस चार्जेस they are inside, still polarized. Means the adjacent site is still polarized. So what will happen when the site A will get depolarized? It will bring about the change in the adjacent. So you write down this difference in potential. This difference in potential between the depolarized site A and the neighboring polarized site B. Sorry, and the neighboring. Shravani, getting my voice? Audible?
Yes, ma'am.
Okay.
Yes, ma'am.
Rumisha, can you hear me? Rumisha, you can also hear me?
Yes, ma'am.
Okay. Now clear now. So what will happen? This difference potential between the depolarized site A and the neighboring polarized site B causes a current to flow. Causes a current to flow between them. Causes current to flow between them. Now what will happen? That current is flowing, so you will find the site B will also get depolarized. Site B जो polarized था वो भी पहले site A polarized state में था, as it received stimuli got depolarized. Now the adjacent site B which was polarized, since that will flow there, you will find.
Ma'am, your voice is not clear.
Is going. Okay. One by one, what is happening? Once the site A received the impulse, it is getting. Okay, once it is depolarized, adjacent site B, there it will cause a current to flow. And because of that, site B will also get depolarized. How it will get depolarized? There also the same process. Sodium ion will start moving outside. Okay, so that
Ma'am, your voice
is not clear.
is not clear.
again it's good. Okay, so I should write down now. Okay. I'm telling that process going on. The site A first it was polarized. Site A first it was polarized. Now on receiving On receiving the impulse, are you all understanding now what I'm writing? Yes or no, Rumisha? Rumisha, speak
No,
up.
ma'am.
Can you see the screen? I'm writing also.
Yes, ma'am.
My screen is visible.
Yes, ma'am.
Okay. So whatever I am saying, I am writing there. So try to understand the whole process. That is how it is entering into the action potential and how the impulse will be transferred from one side to the other. ओके, साइट ए मतलब मेम्ब्रेन के एक पार्ट पे जैसे ही इम्पल्स आएगा तो व्हाट विल हैपन, फर्स्ट तो पहले वो पोलराइज्ड है, लेकिन ऑन रिसीविंग द इम्पल्स यू विल फाइंड इट गेट्स depolarized. It gets depolarized. Understood? Now how it is getting depolarized? So try to understand how it is getting depolarized by changing the permeability. Okay, because जैसे ही impulse आता है तो उसकी permeability बदल जाती है. So what will happen? Sodium ions will start moving. Sodium ions, Neha, what will happen to the sodium ions? Neha, can you speak up?
Ma'am, they goes inside.
Sodium ions move inside. Sodium ions move inside and potassium ions move
Outside.
outside. So because of that, what is happening? It is getting depolarized. Depolarized क्यों बोल रहे हैं अपन? क्योंकि जो उसका polarized nature था, positive outside and the negative inside, that has got changed. So it got depolarized. Now the adjacent region which is in touch with the site A, that will get the current. So you have noted already that neighboring polarized site B causes a current to flow. And when the current will come there means when the impulse will reach to the site B, that will also, there also the same process will be occurring. That is, the potassium ions will start moving outside, sodium ions will start moving inside. So site B will get polarized. Now जैसे ही site B polarized हो जाती है, so you will find site A will get repolarized. Site A will get
Repolarized.
site A will get repolarized. Now how it get repolarized? Now again the permeability will alter. The sodium will start moving again outside and potassium inside. Is it clear? Now you have noted this much causes current to flow between them. Yes or no?
Yes, ma'am.
Okay,
Yes,
now
ma'am.
continue and write down. Thus the action potential generated, take off from the screen. Thus the action potential generated at site A arrives at site B. Arrives at site B. This is how an impulse is propagated across the membrane. So take up from the screen. This is how an electrical impulse is propagated across the membrane. It is already 46 now. Let me finish the last part already. Done, everyone? Noted?
Yes, ma'am.
Okay, I'm changing now the third step, that is repolarization. So what is repolarization? That again, positive outside and negative inside. So you will find here that when the action potential reaches 30, write down repolarization. Third step, repolarization. And note down, when the action potential reaches plus 30 MV, the membrane at site A becomes impermeable to sodium. Impermeable to sodium. So what will happen? Now the sodium will not be entering inside, and permeable to potassium. So from outside the potassium will start moving inside. Impermeable to sodium ions and permeable to potassium ions. Noting everyone?
Yes, ma'am.
Okay. Soon potassium diffuses out of the membrane. Soon potassium diffuses out of the membrane. Now write down the sodium potassium pump, then pumps out 3 sodium, pumps out 3 sodium and pumps in 2 potassium. Pumps out 3 sodium ions and pumps in 2 potassium ions to restore the resting potential. To restore the resting potential. And write it in bracket minus 70 MV. This is known as repolarization. This is known as repolarization. So you can see here in this figure, it's showing better. Site A, it was positive. Now see, this is the resting potential plus outside minus inside. Now site A, as the stimulus reached there, so you will find permeability alter हो गया. Site A में minus up हो गया, means outside and the plus inside. Now site B will receive the current. So what will happen here? You will find the process will be altered, and from site A to site B, then site B to site C. That way the impulse will be transmitted. और जो साइट repolarize depolarize हो जाता है वो फिर से repolarize हो जाएगा. So that process of depolarization and repolarization will continue. Clear to everyone?
Yes, ma'am.
Neha, listening?
Yes, ma'am.
Okay. So rest I will be taking up other period, and I'll be sending one figure to you all. I'll WhatsApp the figure. So I'm stopping the sharing, and I'll discuss one more figure next time. So everyone has noted the 3 stages involved in the nerve impulse conduction along the nerve fiber. Noted everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Yes,
ma'am.
ma'am.
Even she is responding yes. Okay. So we'll take up. I'm stopping the recording also.